Hello everyone. So in the last session we started discussing about linked list and we wrote very simple code. So let us discuss the code one more time. So we have created a class node. So this is a node class and it has two fields, data field and the next field. So the first field is data and then we have a next field. Simple. Then we created a parameterized constructor. Then what we are doing, so we are creating the nodes statically. So node n1 and node n2. So what will happen, you will get the first node, name is n1, address let's say 100. So this is 100 actually. And similarly we have n2 node and let's say its address is 200. So the data is 1 and next is null. Why next is null? Because you can see in the constructor we have put null. Similarly, the data is 2 and the next is null. So currently we have two nodes. Now what you want to do, so in order to create a linked list, we want to create a connection between these two nodes. And in order to create the connection, what we have to do, so we have to put 200 here. So instead of null, I have to put 200 in order to create a connection between these two nodes, in order to connect these two nodes. And with the help of this line, I will be able to create this connection and hence these two nodes will be connected and I will get a linked list. Simple. Then we are just printing the data. So here 1 will get printed and here 2 will get printed. Then what we are doing, so I am creating a head pointer. So I told you, if you have a linked list, let's say this is a very big linked list. So if you have a linked list, then the first node is actually called the head of the linked list and the last node is actually called the tail. Okay, so what this head will contain, so it will contain the address of the first node. So this head is containing the address of the first node, and I told you in the last video, this head is actually not a node, it is simply a pointer, 8 bytes, name is head, and it will store the address of the first node. So in our case, n1 is the first node. We have only two nodes, n1 and n2. So n1 is the first node and its address is 100. So 100 will be here. Simple. And then we are printing the data of the first node with the help of head. So the last time we created the nodes statically. So let's discuss how we can create nodes dynamically. Okay, so let's create nodes dynamically. So what we have to do, so I'm going to create nodes dynamically. So the syntax is very simple. What we have to do, so node star n3, we have to use new keyword, new node, and we have to call the constructor. So the data is 3. Let us create one more node. So node star n4, new node, and the data is 4. We are calling the parameterized constructor. Simple. Okay, so what will happen? So let us try to analyze what will happen at this line. So n3, what will happen? So whenever you do dynamic allocation, so memory will be allocated in the stack as well as in the heap. So in stack memory, you have stack memory as well as heap memory. So in stack, you will get 8 bytes due to pointer. So this is n3. And in the heap, what you will get, so this is data is 3. You can see the data is 3 and the next is null. And let's say the address is 300. So what will happen? 300 will be stored here. Simple. We know dynamic allocation. And at this line, what will happen? So again, in the stack, what will happen? This is n4. Again 8 bytes because the pointer is 8 bytes. So this is also 8 bytes. And similarly in the heap memory, you will get a node, data is 4, next is null, and let's say the address is 400. So 400 will be present inside this box. Simple. Now what you have to do, so these are two nodes, first node and the second node, and in order to create a linked list, what we have to do, so we have to make this connection. We have to connect these two nodes. Okay, so instead of null, what it should contain? It should contain 400. Okay, so 400 should be here in order to obtain a linked list. So what will be the syntax? So in order to create the connection, what we will do? So n3 arrow next. So this is your data field and this is your next. Okay, so N3 arrow next, that simply means reach here. And then what you have to do, so we have to put 400 here. So where is 400 present? So 400 is present inside N4 block. So you will simply do equals N4. If you will write address of N4, that is wrong. Okay, we have to do equals N4. Simple. Now let's do this. So in order to make a linked list, in order to connect these two nodes, what we will write, N3 arrow next is simply N4 and not address of N4. So this is how we can create our linked list dynamically. Simple. Okay, so let's do one thing now. Let's create a linked list with 5 nodes. Okay, so let's create a linked list with 5 nodes. So this is my first node. This is the second node. Similarly, the third node. This is the fourth node, and let's say this is the fifth node. And the data is 1, 2, 3, 4, and 5. And initially, in the next, we will have null. Then what we will do, and we will also create a head pointer which will store the address of the first node. So let's say its address is 100, address is 200, the address of this node is 300, address of this node is 400, and the address of this node is 500. So what head will store? It will store the 100. It will store the address of the first node. Simple. Then what we have to do, so we have to connect all these nodes. So by connecting, what I have to do, so I have to make connection like this. Okay, so we have to make connections like this. So in order to make the connections like this, what we have to do, so each node will store the address of the next node. So I will store 200 here because 200 is the address of the next node. Similarly, it will store 300, it will store 400, and it will store 500. Okay, so once you will store 200 here, then this connection will be established. If you will store 300 here, then this connection will be established. If you will store 400 here, then this connection will be established. If you will store 500 here, then this connection will be established. Now this is the last node of my linked list, basically the tail node, and for tail node, next node does not exist. So that's why it should contain null. And it is already containing null because of our parameterized constructor. Simple. Okay, so let's create this 5 nodes, and for now we are creating these 5 nodes statically. Okay, so let's write the code for creating these 5 nodes statically. So let's comment out everything. Okay, so we have already created these 2 nodes. Let's comment out everything else. Now after creating the first node, let us also create a head pointer. So what head will contain? It will contain the address of the first node. So first node is N1, so it will store the address of first node. Simple. So I have created. Now we have to create 3 more nodes. N3, data is 3. Similarly, node N4, data is 4. And similarly, node N5 and data is 5. Simple. Then what we have to do, so we have to create connections. Now how can we create connections? So it is very simple. So what is happening here is, you will get the first node. This is your second node. This is your third node. This is your fourth node, and this is your fifth node. Okay, so data is 1. Then you also have a head. So let's say address is 100, address is 200, address is 300, address is 400, and address is 500. So at this line, this node will be created, address is 100, then we are creating a head pointer. It will store the address of the first node. So head is containing 100, then create node 2, create node 3, create node 4 and create node 5, and inside next we will have null, because in the parameterized constructor we have written null. Now these are 5 nodes, and what we have to do, so we have to connect these 5 nodes, and I told you in order to connect these 5 nodes what you have to do. So in order to create this connection, I have to write 200 here, and this is very simple. So you will write n1 dot next is address of n2. Similarly, you will write n2 dot next is address of n3. So this connection will be established and 300 will come here. So this is n1, this is n2, this is n3, this is node 4, and this is node 5. Okay. Then you will write n3 dot next is address of n4. So instead of null, 400 will come here and this connection will be established. Then finally you will write n4 dot next is address of n5. Okay, so this connection will be established and 500 will come here. We do not have to do anything with the last node, because for the last node null should be there, and null is already there because of the parameterized constructor. Simple. Okay, so let's make the connection, and after doing all this work we will get a linked list of 5 nodes. Linked list of size 5. Linked list containing 5 elements. Simple. Okay, so let's do this. So n1 dot next is address of n2, and let's copy this. So n2 will come here, n3 will come here, n4 will come here, and similarly n3 will come here, n4 will come here, n5 will come here. So after doing this, I have my linked list containing 5 elements. Okay, so now what I want to do, I want to print this linked list. Okay, so I want to print this linked list. So what should be my output? My output should be 1, then 2, then 3, then 4, and then 5. Okay, so this should be my output after printing the linked list. So for printing the linked list, what we have to do? So we have to create a print function. Okay, so let us create a function print. So let us create a function print. So what this print function will take? So it will take head as input. Now what is head? So head is actually, you can see, so what is head? Head is containing the address of the first node. Head is containing the address of the first node. If you know the address of the first node, basically you know the complete linked list. I'm repeating myself. If you know the address of the first node, if you know the address of the first node, basically you know the entire linked list. Why? Because you just have to iterate. If you will iterate, you will get next node. If you will iterate, you will get the next node. Similarly, if you will iterate again, you will get next node. And similarly, if you will move forward, you will get the last node. Basically, if you know head, you know the entire linked list. That's why in the print function, you only need to pass the address of the first node, and the address of the first node is basically head only. Okay, so let us write print function. So what will be the return type? Return type will be void, because we are just printing. The name of the function is print, and it will take the address of first node as input. So node star head. So how can we print the linked list? How can we print the entire linked list? So let's see. So what do we have here? This is 100. This is 100. Okay. So for printing 1, what we will write? So for printing 1, we will write something like this: cout data of head. Okay, so I will write like this: cout data of head. So I'm writing my output here. My output will be 1. Simple. Now we have to move forward. So we are standing at this node. Now I want to reach this node. So basically I want to traverse. So for traversing, what we will write? We will write head equals next of head. Head equals next of head. So basically this is move forward. head equals next of head. So head is containing 100, and what is next of head? So next of head is actually 200. So this 100 will get updated to 200. Now I am standing at this node. So what I will do, cout data of head. Now what will happen? My output will be 2. Again, you have to move forward, go to the next node. So for moving to the next node, I will again write like this, head equals next of head. So head was containing 200. What is next of head? So next of head is 300. So this will get updated to 300. Now I'm standing here. I want to print this data. So again I will write cout print the data of head. Now this time 3 will get printed, and what I will do, again I will move ahead, then I will print 4, then again I will move ahead and I will print 5, and here it will be null, so I will stop printing. So this will become 400, then this will become 500, then this will become null. Okay, you can see null. So when we will reach null, basically I will stop. Similarly 4 and 5 will get printed, and this is my output. This is the expected output. Okay, so we are doing the same thing multiple times. So basically what we have to do, we will use a loop. And what is the stopping criteria? When your head reach null, that is your stopping criteria. Okay, so we have to write these 2 lines only. Print the data, move ahead. Print the data, move ahead. Again print the data and move ahead, and you have to continue doing all this work until your head pointer reaches null. Simple. Null means basically the last node. Okay, so let's write the code. So what we have to do, we have to simply use a while loop. So while head is not equals to null, so print the data of head arrow data, and you have to move forward. So head equals next of head, and that's all. So this is what you have to do. Okay, we are just moving forward. So let's give some space here. Okay, so I think our code will work. Okay, so I'm calling the function print. So let's see. Let's run our code. Okay, so this is our output 1, 2, 3, 4 and 5. So our code is basically working. Now let us dry run our code. Okay. So what do we have here? So I have 5 nodes. So this is data 1. This is next node. This is next node. Node 4 and finally node 5. So it is containing null. Let's say the address is 100, the address is 200, the address is 300, the address of this node is 400 and the address of this node is 500, and I also have a head. So this is head is containing 100, basically the address of the first node. Okay, and similarly 200 will be here. So it is containing 300, it is containing 400, and this is containing 500. Simple. So we have this connection, we have this linked list. So what I am doing here, I am passing head. So head is 100. So this is main head actually, and this is function head. Okay, so this is function head. So we are passing by value. You can see we are passing by value. Okay. So the main head was 100, you can see main head was 100 and we are passing 100. So this is function head, this is this one. So this is 100, okay. So head is not equals to null, true. Then print the data. So I will print 1. So this is my output. So I am printing 1, okay. Now head equals next of head. So basically head will become 200. Okay, so next of head is 200. So head will become 200. Then again check. So 200 is not equals to null, true. Print the data. So 2 will get printed. Then move ahead. So head equals next of head. So this time it will become 300. You can see. So this is containing 300. Now check. So 300 is not equals to null, true. So print the data. 3 will get printed. Then move ahead. So 400, again check. So 400 is not equals to null. So print the data, 4 will get printed. Then head equals next of head. So 500, you can see this is 500. Then check. So 500 is not equals to null. So print the data. So 5 will get printed. Then move ahead. So for moving ahead, this time it will become null. Okay, you can see this is null. So null is not equals to null. So the condition is false. If the condition is false, you will come out of the loop and your function will be over. And this is your output 1, 2, 3, 4 and 5. Now one thing to note here is basically what we are doing. We are passing by value. Okay, so we are passing by value. So our main head will not change. We are just changing the function head. Okay. So what will happen? Let's copy this code and let's paste it here. So what will happen? My question is, so my linked list will be printed 2 times or not? I'm repeating my question. What I did, I just copy paste this code. Okay, so my question is, will my list will be printed 2 times or not? So the answer is no. Why the answer is no? Because you can see after coming out of this loop, my head is containing null. Okay, so head is containing null and this condition will become false because head is null and this condition will become false. So you will directly come out of this loop. So basically your linked list will be printed only one time. Our linked list will be printed only one time. Okay. Now one more thing. So at this line number 21, what is the value of my head? So the value of head is actually null. You can see. So at this line number 21, the value of head is null. So for example, if I want to do anything with the linked list here, so I cannot do anything with the linked list. Why? Because I do not have the address of the first node. Okay, so when I passed head here, I am passing the address of the first node, but after going through this code, the head value has got updated. Now it is containing, the head variable is containing null. So I cannot do anything with the linked list after this while loop because I do not have the address of the first node. So a better way to do this, what we will do, we will create a temp variable. So what I want to say here is, so let's comment out this. Okay, so what I want to say here is, so instead of iterating with the help of head pointer, I will create a temp pointer and this temp pointer will store the address of the first node. Okay, and we will iterate with the help of temp. So I am iterating with the help of temp. So my head will not change. And this is a good way to iterate. Instead of using the head, just create a temporary variable and iterate with the help of temporary variable. Okay. So now if I will run this code, so how many times my linked list will be printed? So the output is 2 times. Okay. Let's see. Okay. So let's give end line here. So now this time my linked list will be printed 2 times. Okay, so my list is getting printed 2 times. Why 2 times? It is very simple. Okay, so let's erase the screen. So what is happening here? Head. So what is head containing? This is your function head. Okay, this is your function head and this is your main head. So you are passing by value and not by reference. So main head is actually 100 and your function head is 100. Then what you did, you created a temp variable. So this is temp and temp is containing, temp equals head. So temp is containing 100. Then after this loop, my linked list will be printed one time. Okay, so 1, 2, 3, 4 and 5. And then basically this will be 100, then 200, then 300. And finally it will become null. Okay, so your temp is actually null. And at this line, now this time you are printing with the help of head. So head is 100. So again 1, 2, 3, 4, 5 will get printed and this time 100, then 200, then 300 and so on. Okay, so finally it will become null. So again, this is not the right way to do it. We will again create a temp variable. So no need to create temp variable again. We will just assign it the value of head. Okay, so let's do this. So again, what we will do, we will write like this. So temp equals head, and we will iterate with the help of head pointer. We will iterate with the help of temp pointer, okay, not head. So this is temp, and again this is temp. Okay, so my linked list will be printed 2 times. Okay, so the linked list is getting printed 2 times. Fine. Okay, so now let us comment out everything. So let's print the linked list using head this time. Okay, so I want to show you one more thing. So this time I am printing the linked list with the help of head, just like we did above. So what we will do, print the data and move forward. So first print the data and now move forward. So for moving forward, we can write head equals next of head. Okay, so print the data and move forward. Simple. Okay, so let's and here let us write null. Okay, so I am printing the linked list. So let's run our code. Okay, so this is my linked list 1, 2, 3, 4 and 5. Okay, so this was my linked list. Now I told you we are passing head by value. So if I will call the function print head 2 times, then my question is, so my linked list will be printed 2 times or it will be printed just 1 time. Okay, so it will be printed 2 times. So you can see my linked list is getting printed 2 times. So what you can do, after printing null, you can give end line. So you can see my linked list is getting printed 2 times. Okay, and why it is so? Because we are passing head by value and not by reference. Okay, so the function head was 100, and when you call the function, so this is main head. Okay, so main head is 100 and this is the function head. So function head was 100 and then it will become null. So when you will call the function again it will become 100 and it will become null again. Okay, simple. And if you will pass by reference, then it will work only 1 time. The list will be printed only 1 time if you will pass head by reference. Okay, so let's see. So here I am passing by value. If I will pass by reference, so here I am passing by reference, then what will happen? So basically this function head and main head will become equal. So this main head and function head, they are basically same. So after calling the function 1 time, this main head will also become null. And when you are calling the function again, so basically you are passing null. Second time you are passing null. So I will directly come out of this loop and only null will get printed. Okay, so let's see. So you can see this time only one time my linked list is getting printed and the second time null is getting printed because of this thing. Okay, because of this thing. Okay, so what is your work? So basically what we are doing here, so we are creating the nodes statically. We are creating nodes statically and then I am calling the print function. So what you have to do, you have to create nodes dynamically. Okay, so your homework is to create the nodes dynamically and then write the print function. Okay, you have to write the print function for the dynamically created nodes. Okay, so you have to replicate all these works, but this time you will have dynamic nodes. So I will see you in the next video. Bye bye.